Good evening, ladies and gentlemen. Welcome to QGENESIS and welcome for this online session on artificial intelligence. Just to give you a brief introduction about the company, we are coming under the group of Arias group of companies. We are into consulting, IT and IT-enabled services, QGENESIS certifications, corporate audits, training and development, process improvements. We are also into training and development. We are taking care of soft skills and personality development leadership and IT-enabled related trainings and manufacturing related trainings. So today's topic is related to artificial intelligence. So that is a part of our learning and development activities. So sit back, relax, and just enjoy the training session. Just to give you a brief idea about how this session is going to be, the Q&A session will be opened from the beginning, and whatever the questions you have, you can post your questions in the chat window, which you can see on the top screen. So the trainer for today is Ashish Pandey. So he is a well-known trainer with us. And so he will be handling the session for artificial intelligence today. So let me take this opportunity welcoming you all and welcoming our trainer, Mr. Ashish Pandey. So Mr. Ashish, so the floor is yours. You can go on. Thank you.
So very good evening to all of you and welcome to today's session of artificial intelligence. In this session, I'll be walking through introduction to AI, its application, and then we'll understand different terminology related with artificial intelligence like deep learning, machine learning, data science, and we'll discuss the different industrial-based application related to the insurance, finance, manufacturing industry. And then after we'll talk about deployment of AI model into the production environment. So let's get it started with introductions to AI. As we know that now AI is booming the market and is becoming very popular. All IT industries, all service industry, manufacturing industries are implementing and adopting this technology. And using the artificial intelligence, or you can say using AI algorithms, they are designing some intelligent software and automating their functions area. So in the simple word, you can define artificial intelligence is a technical science that studies and develops theories, methods, technologies, and applications for simulating and extending human intelligence. Or using to the AI, we can design some intelligent computer program or intelligent machine which can perform some tasks normally require human intelligence. Let's say to understand human languages, to predict, for the prediction of a recommendation purpose. We use intelligence, and using that we can perform some action. Similar way, now industries are using AI to automate their all entire functions area, and they are using the AI algorithms, and they are working with a huge amount of data and building some intelligent software. So a different way we can define artificial intelligence. We can say the AI is all about study of human brain because we want to design some intelligent software which can perform or which can think into similar way like intelligent human can perform some task, or intelligent human can perform some kind of the task or behave. Or you can also say AI is a capability of machine to imitate intelligent human behavior. So different way we can define artificial intelligence. And if I talk about AI development history, so AI is not a new technology. John McAfee, who is known as the father of AI, coined artificial intelligence term into 1956. And then after, there are lots of mathematicians develop different theories, come with the different algorithms which can easily simulate human intelligence into some software. And nowadays we are using AI into our daily life. If I talk about some applications like Google Assistant, Siri, Alexa, chatbots, recommendation systems like Netflix, e-commerce, Flipkart, and Amazon's e-commerce companies, they're using for the recommendation purpose, they're using artificial intelligence algorithm, AI-based algorithm, self-driving car, Google Lens. So these are some popular example of artificial intelligence. Not only the service industries, nowadays manufacturing industries, they're also using AI to build different kind of applications like predictive maintenance, recommendation solution, or to predict some breakdown or the failure of any machine. Let's understand and discuss this all over different use cases into detail. If I'll talk about applications of AI, so now in all industries, all kind of industries, nowadays they are using artificial intelligence, banking, finance, insurance, government bodies, supply chain management, smart cities, like lots of the startups, agriculture sectors, into manufacturing industries, IT industries, service industries, all kind of industries nowadays, they are using AI and developing some intelligence software or building different applications. Or to also build end-to-end data-driven solution, nowadays industries using AI algorithm. Some of the algorithm and some of the applications like manufacturing industries using AI to design some predictive maintenance, prevent maintenance, demand forecasting, sales forecasting, to build such kind of the application. Retail industries, especially like Amazon Go, one of the retail shops, so they use computer visions, IoT, sensor fusion, such kind of the technology to build some, to improve the particular customer experience into the some shopping malls. Finance industry, banking, insurance, all the industries, they are using artificial intelligence to automate all the functions area to predict the particular credit worthiness or for the evolutions, okay, or for sales marketing, campaign management. For different purpose, nowadays the financial service industries are using AI. Similarly, travel industry for dynamic pricing, like even all airlines companies, all IRCTC, Indian Railways are using artificial intelligence for dynamic pricing. Medical industry nowadays using artificial intelligence for drug discovery, understand medical images like MRI, CT scan, okay, and they using the artificial intelligence for drug discovery. And also nowadays energy and feedstock and utility, different industries are using artificial intelligence for different and developing the different solution. So there are lots of platforms that we will discuss about, like Google DeepMind platform. They design the particular AI-based software or simulator software. They can taught itself like how to walk, run, or jump. Okay, using to the reinforcement learning algorithm. And this is the particular Amazon Go. Amazon's Go using the artificial intelligence, computer visions kind of algorithm, and sensor fusions, IoT, the different technology to improve the particular customer's experience into some retail shop. Cybersecurity industries nowadays using the artificial intelligence to improve the security to predict the threats into real time. Agriculture industries and government bodies nowadays using the artificial intelligence and different especially like robotics sector. And this is in this picture, as you can see, this solar power robots is able to using to the computer vision technologies is able to kill the weeds. So there are some advanced intelligence CCTV cameras, okay, and that will able to monitor all over the weeds and automatic using to its arms generally keep the all over the weeds over there. Even now government bodies and lots of the startups, they are designing some AI-based artificial intelligence-based Android application for the farmers. In the banking industry nowadays, all HDFC, ICICI, all different banking industries nowadays, even SBI, all the different banking industries are using artificial intelligence to provide better customer services like chatbot. Even they are also deploying some AI-based physical robots which can provide the customer supports, serve the particular customers and solve their queries. If I talk about some industries like Amazon's, Flipkart, and such kind of the e-commerce industries, and also like Netflix, there are some application of the recommendation system which is also based on artificial intelligence. Even if I talk about the robotics, could even Honda and different industry who design the physical robots or mobile robots, you can say, and also for industrial robots like KUKA, Fanuc, ABB, such kind of industries, nowadays they're using artificial intelligence to design some intelligence, to feed some intelligence, or designing some smart and intelligence robot. Even sales, marketing, HR, management, all we can use the artificial intelligence and come with some intelligence software which can provide or solve some particular business problem. There are some startup that design the particular AI-based some software which can analyze all of the persons, their social networking platforms, emails, Twitter, LinkedIn, Gmails, and provide the best suggestion based on the particular information. Even the lots of industry, they come with the different AI-based application for the healthcare industries. Okay, like for the early diagnosis, for the skin visions, like one of the applications where we can just upload some of the images of the skins, and if there is any, so it will just recommend the different kind of the it will be detect the different diseases related to the skins and also recommend the different solutions or medicines. So you see that now all the industries are talking about artificial intelligence and they are implementing this particular part. So let's understand how does this actually work, okay? And how to implement into the real world. Because nowadays all industries, they're talking about AI, they're implementing, they're adopting these particular technologies, because using that they can come with some intelligence software which can take some decisions into the similar way like a particular intelligence human or experienced person can take it, and they are automating all over the functions area or the productions area or improving the productivity using to the such kind of the technologies, new edges of technologies. So you can say the AI is some powerful algorithm, and algorithm is some mathematical function, and now due to digitalizations or for IoT, now all industries like all the government bodies and all private sector of industry, manufacturing industries, they have a huge amount of data, and they are using the artificial intelligence based algorithm to feed intelligence or to build intelligence into some computer or software, and then after that deploying that particular intelligence software into their production environment and building the end-to-end applications. Okay, so whenever we say the AI, then machine learning is come in the picture, and lots of the people talk about AI and ML. So now let's understand what is machine learning. So you can say AI is collection of algorithm. Okay, AI collection of lots of different algorithm like genetic algorithms or optimization based algorithm, fuzzy logic, searching algorithms. So AI is a collection of different algorithm which can be used for different purpose. Okay, and machine learning is subset of AI. It's also the collection of algorithm, or you can say is a collection of powerful algorithm which use a data to build intelligence. As we know that nowadays everyone is talking about data, and because if you have a data, so we can do lots of things. We can come with some intelligence software which can perform the different action, which can take some decisions, or we can automate some of the functions area, or we can perform analytics and we can find the insight and improve the particular business decision making process. So now let's understand the machine learning into detail and also talk about the working part. And if you can see, if I talk about artificial intelligence, machine learning, deep learning, so all these things are related to each other. So as we discussed, artificial intelligence are collection of algorithm. That algorithms, any learning agent can be use it and build the intelligence, okay, or become the intelligence. So AI is a collection of algorithm, okay, that can any learning agent like any software, any computer program can be use it and learn from the data and become intelligent. Okay, some of the algorithms use a data to build intelligence. Some of the algorithms don't require a data. Some of the algorithms is fuzzy logic, genetic algorithms, searching based for the different applications. But machine learning is collection of the powerful algorithm which use a data to build intelligence. And that's why nowadays machine learning is very famous, very popular, because now all the industries, they have a huge amount of data, and using a machine learning algorithm, they can build intelligence, they can come with some intelligence software which can perform some action, which can take some decisions. Okay, now let's talk about the deep learning. So deep learning is again subset of the machine learning. Okay, in the machine learning, there are lots of algorithm like which linear regression, logistic regression, decision tree, random forest. There are different algorithm. Okay, an algorithm is just mathematical function. Okay, so one of the algorithm is artificial neural network, which is based on human brain function. When we say the human brain function, it means that, you see, generally we say the humans are very intelligent because we can take some decisions, we can give the recommendation, we can understand the charts and graphs, or we can perform some action based on the situation, right? So similarly, the mathematician, they come with some proper algorithms, one particular mathematical function which is similar to the human brain mechanisms, that is artificial neural network. So ANN is based on human brain function. Like in the human brain, there are lots of neurons, and all the neurons are connected to each other, and they process the data, and based on that sometimes we perform some action. You see, we collect through our human body, through the different sensors, we collect the data, and all of the data move to our brain, and in the brain there are lots of neurons which is going to process those data, and based on that we perform some action. Similar way, mathematicians come with some algorithm, that is artificial neural network. It's work into similar way like how our brain processes the data. Okay, and similar way we can process those particular data and design different kind of algorithm solutions. So extension of artificial neural network is known as a deep learning, where we talk about some of the very powerful or popular algorithm like convolutional neural network, recurrent neural network, or LSTM, and we can build different kind of the applications like a chatbot, like text to speech, speech to text, object recognition, face recognition, object classification, okay, and such object segmentation. Such kind of applications we can be designed. But at the same time, industry, they also talk about the data analytics and data science. So let's understand this particular part also. As you can see now, mostly industry, they work with the particular structured data. You see, as we discussed, we are talking about algorithm. At the same time, we have a data also. So your data may be structured or unstructured. Structured data means whenever you have a proper shape and size of data, like let's say you have some CSV sheet of data or Excel sheet of data, very proper shape and size of data, it is known as structured data. Unstructured data means there's no any proper fixed shape and size. Let's say like a particular images or the videos, audio file, text. So such kind of data set is known as unstructured data. So mostly industry work with the structured data. Most of the time, most of the industry, they use a structure. They have a structured data, like especially like banking, finance, insurance, or IT industry, service industry. They have proper structured data, and they work with a particular structured data. Okay, so there's a one field. Okay, and use of that we can work. We generally work on very structured data. That is something known as data analytics. And inside of it, we perform a particular, we apply the statistics, we apply the graphical analytics, like statistics means different descriptive and inferential statistics. We apply on the data and find out the past event or hidden patterns. Then after, all the senior manager can be use those information to improve their decision-making process or to change some their policies. So data analytics, mostly industry perform it to find the insight or to extract the information. Okay, and then after they design one particular proper reports, and submit the report to the senior managers or the VC, and they use those information and improve their their decision making process, or also help them to change the policy and to know the particular all the past event or the past event, or analyze all over the past event, you can see. Okay, so that is something the data analytics, and there are different tools that and different ways that we can be performed, like graphical analytics, where we plot or draw the different interactive graphs between different variables. Okay, and we try to draw the one particular design one proper reports over there. And second is we use a statistical analytics, where we use descriptive statistic or inferential statistic, like in the inferential statistic, ANOVA, chi-square, t-test, different kind of the hypothesis testing, we do that. And second is descriptive statistic, where mean, median, mode, then distributions of data, okay, correlation, covariance. So we generally apply on the data and we try to analyze it or extract the particular hidden information or analyze the past event, you can see. Okay, and the combination of the particular, you can say, the data analytics and some AI algorithm, it is known as data science, DS. And DS is nowadays very, very popular, which is the combination of the particular AI algorithms or machine learning algorithms with the data analytics. And using this particular part, we can build some predictive models based on the past event. So when we say the particular predictive model, now all the industries are using a data science technique and designing some predictive models. Okay, now let's say a particular banking industries, they are deploying some AI model on their server. So all of the customers from the Android application, they can go and check it whether like they are eligible for such kind of the loan or schemes or not, or credit card or not. So in that case, we through the particular Android application, we just feed some set of the features, some set of the information, and click on submit button, and through that we'll get some response that whether like we are eligible for loan or not, or for credit card or not. So actually behind it, the AI is actually work. The company deploy one AI based model on their server, and whenever we submit the particular, whenever we hit the particular submit button after sending all the features, generally all the features move to the particular company server, and on the company server there is an AI model. We generally predict that based on the particular past data set and give the response to us. Even now, all the industries nowadays, they are talking about the data science and implement it. So here the particular softwares use AI algorithm to build some predictive model. Okay, there's also the similar field which is talked with the, so here in the data science or data analytics, we mostly deal with the particular structured data set. Mostly we deal with the particular structured data set. And there's also one field where we similar to one field where we generally analyze the images or the particular video without audio, and that we process such kind of the images or video and analyze it. And this field is known as image processing. And here we use some normal linear algebra, some probability based function, normal calculus functions that we use it, and we process the particular images, we apply the filter, and we to perform the particular image processing. Let's say in the particular image there's some noise, or you want to increase the particular brightness or something. So we just use a normal image processing functions, or which is based on some statistical or some linear algebra, and we can do this particular part. So there's no any AI. Okay, but same time, by the combination of the particular, or you can say the combination of image processing and AI algorithm, it is known as CV, computer vision. And nowadays all the industries, they are using the computer visions or computer visions applications, or building a different solutions like smart or intelligent CCTV cameras, which are able to recognize in the real time whether like person is using a face mask or not, okay, or maintaining the social distance or not, or the particular or RTO. Nowadays they are using the computer visions based algorithms to recognize in the real time to recognize the particular whether like person is using helmet on the public while driving the bike or not, okay, or to recognize the particular number plates. For that they are using the particular computer vision based algorithm. Okay, so here we mostly deal with the particular images and video without audio, such kind of data set, and build such kind of the intelligence into some software, and we can design it like object detection in the real time. If there is some object is moving, so using with the help of the CCTV camera, we can recognize that whether like object is car or the person or some other object. Similarly, we can also video analysis. For the different purpose, we can use a computer vision algorithm, which is the combination of AI algorithm and image processing. Okay, there's also one field where we analyze the particular audio data set and text data set, and build the different, we apply the normal sum functions and analyze that particular data. And the combination of this particular AI algorithm and audio and text data set, it is we generally say as NLP. And using to the natural language processing nowadays is very popular. All the industries nowadays, they are using the NLP to design the chatbots, and some of the very famous deep learning algorithms that we use it like RNN, LSTMs, or to analyze the particular sentiment analysis application, text classifications, or entity recognition. Okay, so even text to speech, speech to text, such kind of the solutions we can be design it using to the NLP, which is the combination of the text mining or audio processing with the AI algorithm. So AI is very, very vast. It's a collection of the different algorithms. Some of the algorithms are very popular. Some of the algorithms are very, very powerful. Some of the algorithms use data to build the intelligence. Some of the algorithms used for different purpose, like for the searching. So there are lots of algorithms there are, and based on our requirement, we can select the algorithm and we can implement it. Yeah, but mostly industry, they're talking about the machine learning algorithm, and even into the computer vision, most of the times we use a machine learning algorithms. Even in the data science also we talk about the machine learning. Even at the same time in the particular NLP also we generally implement we use a machine learning algorithm to build the different application. And the reason is machine learning algorithms is use a data to build intelligence. Okay, use a data to build intelligence. So if you're working on the machine learning, so you can say that we are working on AI, because machine learning is subset of AI. Same time, the deep learning is nowadays all universities and all industry, they're using a deep learning algorithm to design the that we can use into the different way to design the particular deep learning algorithm. Even nowadays there are lots of research is going on the deep learning algorithms only. So even the chatbots and the particular text to speech, speech to text, or generate some particular fake images or the fake videos, or to recognize the fake content on the internet, we can be used deep learning algorithms and build such kind of the solution. So it's very, very popular, and nowadays widely famous, and researchers and some universities, they work on deep learning algorithm, and all the scholars and PhD students, they do thesis on the particular deep learning algorithms and design the different architecture. So it's very popular nowadays. While the research is going on the deep learning part, and different product companies are using a deep learning algorithm to build different solutions. And mostly IT industry, service industry, they use a normal machine learning algorithm. So deep learning is also subset of machine learning. So as we discussed, machine learning algorithm use a data to build intelligence. Then again, deep learning algorithms is also use a data to build intelligence. You can define, if I talk about the normal as a definition wise AI, ML, and DL, so you can define into the different way. Like as we discussed, AI is a technical science that studies and develops theories, methods, and applications for simulating and extending human intelligence, and how using to the algorithms. So there are different algorithms. Some of the algorithms is based on optimization techniques, some of the fuzzy logic, some of the different rule based. So there are different algorithms, and some of the algorithms is based on rule, some of the algorithm based on probability and statistics, some of the algorithm based on optimization techniques. Okay, so AI is just something, a technical science that studies and develop the different theories and methods and application to simulating and extending the human intelligence. But machine learning is very popular because machine learning algorithms is use a data to build intelligence. Okay, and when we say the particular use a data to build intelligence, and after this particular process, we can design some intelligent software or intelligent computer program which can solve the particular some business problems or particular predict about the particular futures or any we can build an end-to-end data-driven solution, right? And again, the deep learning is extension of the artificial neural network or multi-layer perceptron, which is the based on human brain function. So now let's discuss into detail machine learning, because machine learning is very popular and industries are using the machine learning algorithm to build different kind of the solution. We discuss machine learning is a collection of algorithms, okay, which use data to build intelligence, and all the algorithms. So there are the three types of the machine learning algorithm. One is supervised machine learning algorithm, unsupervised machine learning algorithm, and reinforcement learning algorithm. Okay, supervised machine learning algorithm use a labeled data set. Use a labeled data set to build intelligence. Unsupervised learning algorithms use unlabeled data set to build intelligence. Okay, we use unlabeled data sets, and reinforcement learning is based on feedback and reward basis. So now let's understand this particular terms and discuss into detail. So as we discuss, machine learning algorithms use a data. So it's something like we require a data. If you're working with the supervised, unsupervised, or the reinforcement learning, we require data, the first thing. Okay, but if you're dealing with a supervised machine learning algorithm, then we require a labeled data sets. Labeled data set means in our data, if there is an input also and output also, like dependent variable and independent variable. Let me give you one example. Let's say a particular bank industry, they want to a particular bank industry, they want to design a particular any bank. Okay, they want to design some intelligence software which can, and then after they want to deploy into their production environment to automate all over the functions area or loan process, all over the loan process or home loan process, you can say. Okay, so in that what happened nowadays, what happened, the people directly contact to all executive or the particular salespersons or the particular technical persons of a bank and ask for the particular home loans, and then after they send some of the details, and based on that bank do some kind of the evaluations and spend some times and check all over the things, and based on that they say that you are eligible, fix that, check it whether like person is eligible or not by checking the credit history of the particular persons. Okay, so now the bank want to automate this entire process, right? So generally what the bank are doing, so the bank just, so now as we know that now all the bank industries have some IT industries or IT teams. So their IT teams, their data scientists use a historical data set, and in their historical data set, they use a labeled data set. Means in the past, the customer who took the loan and particular customers who apply the particular home loan but did not get it, did not got. Okay, so they have a loss of the huge amount of data set where the some of the particular whether like person is eligible for the home loan or not. It depends on the loss of the features like their income, their salary, employed or not, education, address, property. So loss of depend on the loss of the features. So now the bank in using bank IT teams are using a particular label data set. Means if the features was this one, so in the past this particular customers got the loan. If the features was this one, then particular customer did not get a loan in the past. Okay, so this is something where we have label data set, like set of the input and output, set of the input and output. So input is known as a particular independent variable, and output, okay, which is the outcome, okay, whether like person got the loan or did not get a loan, So this is something output, it is known as a dependent variable. So if in our data we have independent variable and dependent variable, so such kind of data are known as label data set. So supervised machine learning algorithms use a label data sets for learning process. Okay, unsupervised machine learning algorithms. So whenever we have unlabeled data set, so we can use some unsupervised machine learning algorithm. Okay, unlabeled data set means, let's suppose that you are going to some grocery shop or some particular Reliance Fresh or anywhere to purchase some items or some particular different vegetables or different things. And after that, the shopkeeper generally asks for your opinion, your particular feedback, and in that we generally give our feedback in the form and also give some set of the information like our name, our address, occupation, okay, and the particular then rewards and some of the details we generally submit. So such kind of data set where we have only the some set of the variable, there is a no input, no output, we just have a some information. So these are some unstructured, unlabeled data set. Sorry, these are some unlabeled data set. So whenever we have such kind of unlabeled data set, so we can use unsupervised machine learning algorithm and build some different solution like anomaly detection, recommendation solution, clusters we can define that, okay, clustering we can be perform it, or dimension reduction. So different things we can be performed using to the unsupervised machine learning algorithm. And reinforcement learning algorithm is also nowadays very popular, but mostly reinforcement learning algorithms is used into the university. They mostly use it, or robotics industry, they use a reinforcement learning algorithm, which is based on feedback and reward basis. Okay, it is most similar to how a particular human or the kids learn bicycles. No one teaches them like you should apply this amount of the force on this pendle and this pendle, and then you will move the particular forward. It's something hit and trial methods or way a particular kid learn the bicycles, or the environment is also very dynamic. So similar like reinforcement learning algorithm is also work. Okay, and nowadays is widely used into the gaming, like to chess game, and also like robotics industries, they are using the reinforcement learning algorithms. Okay, so as we discussed, supervised machine learning algorithm use a label data set for training the process, and after once it's trained that, it will able to do some kind of the prediction. Because supervised machine learning algorithms use a label data set for learning process. So after the learning process, once it's become the intelligence, so it can perform some testing, or it can do some kind of the prediction. And mostly using to the supervised machine learning algorithm, we solve two kind of the problem. One is regression and second is classification. Regression and classification. Regression algorithms will able to predict some continuous value, and classification can predict some class. Okay, so regression can predict some class, particular some continuous outcome, and classification can predict some different class. Let's understand this particular part. So let's say you want to design some application which can predict the age of the person. So here we can use a regression algorithm, because we want to predict that in our business case. Every times our model want to predict that, or we want to predict some age of the person for the different customers or different person. So this is something regression problem we have, and in order to solve the regression problem, we can use a regression algorithm. And for the classification algorithm can predict some class or label. So let's say if you want to design some applications, and in that you want to check it whether like person is eligible for loan or not. Okay, so here or some breakdown will be come in the machine or not. So such kind of the classification problems, here we want to try to predict the class, and class may be 1 or 2. Let's suppose that you want to design some application or some Android application, some kind of the artificial intelligence based application, which can in the real time, which can recognize a particular flower and perform the classification, recognize that whether like it is a lotus or the sunflower or the particular some other different flower, right? So it may be the 2 and maybe more than 2. So whenever we want to perform classification, we want to predict some class, so we can use a classification algorithm. Whenever you want to perform or predict some continuous value, so in that case we can use a regression algorithm. Okay, and as we discussed, unsupervised machine learning algorithm that we can be used for clustering purpose, anomaly detection, recommendation solution, we can design using unsupervised machine learning algorithm. And first thing, but clustering is very popular, and mostly we use for market segmentation, like industries are using unsupervised machine learning algorithm, or for anomaly detection, or for recommendation purpose, they use unsupervised machine learning algorithm to build such kind of the solution. Okay, so let's say in this figure you can see there are different information or data, different type of the particular data. Let's say there's some triangle. Okay, as you can see here. Okay, there are some kind of the square or the different kind of data that we have. And so let's say you can see this triangle is represent the particular sports article. Okay, and this is something of politics, and this is something you can say particular some articles related to the particular music or the history. Okay, so if you use some particular machine learning algorithm, so what it's going to do that it will be define some clusters. Okay, some clusters. So there are 3 cluster this algorithm or unsupervised machine learning algorithm is coming with the 3 clusters. And cluster means, why I'm saying this cluster is, it is not classification, it is a cluster. It is not predicting something, it is defining some cluster. Cluster means a group of data which is representing the same kind of information. A group of data which is representing the same kind of information. So this is not prediction. It's not predicting that whether like this will be moved into the triangle or something. It's just defining the cluster. It may be right, it may be wrong. Okay. And if we have a particular business understanding or data information, so we can do the interpretation of it. Then again, the reinforcement learning nowadays is very popular, and mostly we use research industries now. Research organization, they generally use a reinforcement learning, and also some scholar students, they generally work on, or the gaming industry, they use a reinforcement learning algorithm. Okay, so the reason is it's very expensive and time consuming. Okay, so in this here what happened, the particular learning agent or the learning agent like computer program or any computer program or any particular physical robot, it directly interact with the environment, okay, and collect some data, and based on that is perform some action. If action is good, so it's got some rewards. If the action is bad, so it's going to discard discard that particular information and don't use it to perform some more action into the future. So it's a very time consuming, and nowadays it's used into the particular field of robotics also, medical sector also even. And supervised machine learning algorithms can learn from the particular data, okay, and as we discussed, is use particular data and is use label data set. So supervised machine learning, whenever we are performing the supervised machine learning algorithms, we use a label data set. So here we know that after the training process, what the model will be do that. Okay, like, because here we know that here we providing a training with a label data set. So here we model know that after this particular process, this model is going to perform this action, either like a regression or the classification. But into unsupervised machine learning algorithm, because it's use an unlabeled data set and it performs some clusterings or recommendations, so we don't know what will be like future outcome of it. Okay, so here in this particular case, you can see here there's some particular car, this very small projects, as you can see, and there's some kind of the particular robot, and first we designed the particular very normal path of it using to the some white and black paper. Okay, and we collected lots of data using a mobile camera, manually move the this particular robot over the path and collected a label data sets. Okay, and it means that, so this is some remote control car, and place my particular camera, mobile camera, over this car, and whenever I took some actions like a forward, backward, left and right, mobile camera is going to click some images of the path and store all of our data in my, I'm collecting all of our data into my laptop with actual label. So let's suppose that at a moment when I took a particular left, mobile camera is going to click some images of the path and save these images in my laptop with the name of the left. Okay, so first we collected a use of label data sets, and then after we use artificial neural network algorithm to train this model and deploy in some local network. During to the testing time, what happened? So this particular robot is collecting images, first clicking the images of the path and sending those images to my local network. In the local network, there's already trained model, so it's predicting that, or it decide that whether like it should be moved or the forward, backward, or left or right, and based on the robot decide that and move into the forward, backward, left or right direction. So it's more on self-driving car of concept. Okay, so here this particular robot is just using the image sensor, and using that it's real time is taking the pictures and sending those images to the AI model, and AI model give the instruction or predict that whether like it should be moved into the forward, backward, left or right direction, and based on that it's moving on those particular direction. Okay. As you can see here, it's also playing. In this particular video clip, as you can see here, this during the testing type, a particular first we collected lots of data set and trained the model and deployed the particular final trained model on some production environment and connected the car to the local using to the some Wi-Fi module connected to the local network. And so during to the testing time, mobile camera is just taking the images and sending the particular images to the trained model, and trained model is predicting that whether like it should move left, right, or forward or the backward direction, and based on that this particular car is performing the action. Okay, so in the unsupervised machine learning algorithm is more on a particular learn into the real time. Okay, into the real time, as you can see here. So let's suppose that you want to design some robot which can move into the forward direction or the backward direction, but here we are not going to give directly a power supply to the motor so that it will be move into the forward or the backward direction. Here we want that robot should be able to teach, learn that, or it will be taught itself, okay, that how to move the forward, backward, or left or right. It was similar way like kids learn a particular how to run or jump or the walk or bicycles, you can say that. Okay, so similar way we can also use a reinforcement learning to design such kind of the interactive projects in the field of robotics, or we can also use into the gaming industries or into the particular robotics or healthcare sectors. We can use it reinforcement learning algorithm, but again it's very time consuming and very expensive. Okay, as you can see in this small video clip, so model is actually, this robot is actually trying to learn that how to move or how to like walk into the forward direction. Let's see here. Let's go with this small video clip. So as you can see here, this particular robot is trying to learn into the moving, learning that how to move forward. Okay, so let's see here. And now after the loss of time, now it's learned that you can see. So such kind of the application we can design using to the reinforcement learning, right? So if you summarize the entire part, so as you can see, the machine learning, there are three type of the algorithms, okay, that is supervised, unsupervised, and reinforcement learning. Supervised machine learning algorithm use a labeled data set where in the data there is some independent and dependent variable. Unsupervised machine learning algorithm deal with the unlabeled data set, and reinforcement learning algorithm generally learn based on the reward and feedback, and it's learned from mistakes. Okay. And using to the supervised machine learning algorithms, we can build solve the regression and the classifications problem. And the classification problems means where we want to predict some class, and class may be the binary or maybe more than two class like categorical, maybe more than two different classes they may be. Into the regressions where we want to predict some continuous value. Okay, let's say predict the particular housing price or age of the any particular person is something a regression applications. And it's very important that, so when we say that we have a data, we have different algorithms, and we can use our learning agent. Means we have a three things. You see, we have a data, we have a particular first thing is data or the information. Second part is, you can say, algorithm, AI based algorithm, and is third one is learning agent, means your computer or the particular your software where you want to build the intelligence, your machine, you can say, right? Okay, so now your machine or your learning agent can be used a particular, with the help of the algorithms, it can learn from data and become the intelligence, right? So when we say that it can learn from data, so during to the learning process is actually learn pattern inside of data, and then after it's become the intelligence. So when we say, so what is the relation between the pattern and intelligence? So generally we say the humans are very intelligent. So in order to recognize our family members, or in order to recognize our friends, so we don't use some set of the rules, right? If the eyes are wider, or the particular lips and particular face structure is the eyes are something 2 centimeter, or the particular lips are something 3 centimeter, then this is our this friend, otherwise this is our parents or our particular brothers. Okay, so we don't use some set of the rules, so our brains use structure, right? Based on facial structure, based on the patterns, we generally try to recognize any object or any of our family members. So that's why we say that we are intelligent, right? So similar way, during to the learning process, okay, or during to the learning process, a learning agent learn the pattern inside of data, okay, and then after, based on those patterns, it perform the particular classifications or the regressions, or build the cluster, or perform the clustering, or build different kind of the applications we can be designed. So during to the classifications time, or after the learning time, after the learning process, during to the after the learning process, or in the classifications problem, learning agent generally draw the particular decision boundary, and on the behalf of the decision boundary, it perform the classification. But in the term of the regression, after the particular training process, learning agent will draw the decision line, and on the decision line, it perform the regression. Means on the decision line, it predicts some continuous value, or in the decision on the behalf of the decision boundary, it perform the classification. Or in the clusterings, it create a particular separate all over the data which having the similar kind of the properties, and that set of the data is known as the clusters. Okay, so that's something we do. Okay, so in the regression, we nowadays we can be used it to build some particular, okay, in the different, like in order to predict the demands of the goods and services for any restaurant chains, we can use a regression problem. Okay, or particular a company sales base of the company can be used the particular regression algorithms, okay, to predict the stock market price of any particular company. Or the medical industry, they can also use a artificial intelligence to build the different solutions here. Okay, so even like you can say the particular any particular financial industries or any banking industries can be used the artificial intelligence to predict, to build some solutions to predict the credit score of any particular persons. Okay, classifications like email spam classification, object classifications, bank churn modeling, churn prediction, in some kind of the terms we can use a classifications algorithm. Clusterings, in the widely used a clusterings to in the field of the data minings, or in the field of the particular healthcare sectors, we use a clusterings to design the different clusters. Even a particular image processing, data analysis, pattern recognitions, we use a clustering algorithm. And market segmentations, we use a particular clustering algorithm. Marketing company, they generally use a clustering algorithm to define, to understand the, to classify the particular type of the customers, and based on that they launch their product. Okay, so the clustering is also widely used to build some recommendation solution or anomaly detection or for okay, so that's something unsupervised machine learning algorithm we can be used it, and clustering is one of the application of the unsupervised machine learning algorithm that we can be used. Okay, like reinforcement learning algorithm can be used for the gaming industry, for aircraft controlling and robot motion control system, in the business strategy planning, or robotics for industrial automation, we use a reinforcement learning. Okay, now it's very important to understand it. when we say the particular in AI, we are using some in AI, whenever we are using some algorithms, and with the help of the algorithm, learning agent is learn from data, learn the pattern inside of data. So it's totally different from a traditional decision making process. It is not something if else, or lots of the conditions, and based on that it perform the action. It is not like that. Okay, so through the AI, learning agents use AI algorithm and try to learn pattern inside of data. Okay, try to learn the pattern. If the pattern maybe try to learn all of the patterns, and based on that it perform action, and okay, it perform the particular action. So it's not kind of the traditional decision making process. Okay, so AI is not something if else condition. It's generally learn the pattern inside of data, and based on that it performing some actions, okay, or predicting some particular outcome. And if I talk about the algorithm, so now let's talk about the algorithm and data, because from many hours that we are talking about different kind of data like structure, unstructured, audio, video, or some CSV, Excel sheet format of the data, and also like different algorithms that we have discussed, like different linear logistics, or the different mathematical function, different kind of data. So actually, with the so you see that humans can generally if I talk about how we become intelligent, so we can become intelligent after the loss of learning process, and we learn from the particular, for the learning process we we learn from the book. With the help of the books we collected a data, and we have a brain. So using a brain we can understand the data, we can learn from particular our mistakes, and finally we become intelligent become experienced, or become very intelligent or expert into the particular domain. So similar things we do with the AI. So whenever you want to design some very intelligence software, okay, so we also require the two things. One is the particular data, and one is algorithm. Okay, and if I talk about all over the learning process, so it's very important to understand this particular part. So our learning agents use a data, and it's learn the pattern inside of data, and based on that it predict the outcome. Okay, and do the kind of the prediction. But it's very simple to say that. But if you'll understand all of if we'll talk about the internal process of it. So what happened is actually, because as we discussed into the supervised machine learning, our learning agent use a label data set. So all the features value is generally moved into some model, like some algorithm, you can say. We use some algorithm, which is a mathematical function, and let's suppose that you want to design some software which can predict the price of the house. Okay, so here we are using some algorithm part, and in the algorithm we just send some features of the house, like age of the house, okay, area, or tax rate, or crime rate. We can be send it, and model is generally model is use some algorithm, which is some mathematical function, and predict the particular output. Like it is a work into the similar way how we do the prediction. Let's say if I give the task predict the price of the house based on age, area, tax, and crime rate. So you can do the prediction, but again maybe in our prediction there will be high amount of error because we don't have experience, right? So here also the algorithm is just use some random value of all of the variable inside of the mathematical functions and do the prediction. Then after it compare the predicted output with the target output, means because we have a label data set also. So in the label data set we have input and output, both things, and compare the target output with the predicted output and calculate the error. If the error is very high, then after, in order to reduce this error, so, and because if you're getting the high amount of error, so who are responsible? The sum of the factor inside of the algorithms are responsible for it. So using to the some optimization techniques, it try to find some optimized value of those variable where the error will be very less. And after the loss of iteration, it learned that it got the particular some optimized value, or learned the particular some optimized value for the given data sets. And then after, during to the testing times, it used those optimized value to perform the some class prediction part. Okay, so this is how a supervised machine learning algorithm is actually work. And there are lots of the optimization methods, like but one of the famous is gradient descent. Okay, that we use it mostly in the field of the deep learning or machine learning part. Okay, so okay, fine, we have lots of data, and we can use different algorithms. We have different algorithms like linear, logistic, k-nearest neighbor, decision tree, random forest, support vector machines. Okay, different algorithms that we can be use it. Okay, and we have a huge amount of the structured, unstructured, business, different finance, or different kind of data set. And our learning agent can use those data, and with the help of the algorithm, it can learn the pattern and build the intelligence. Okay, it's fine. But how to implement into the real world? How to implement into the real time? Okay, because we have a data, we have algorithm, but how to implement into the real time is it is a very important thing, right? So here we're going to talk about the different platform and different tools that is widely famous for implementation purpose. Okay, and one of these scikit-learn is widely famous. The scikit-learn, this particular platform, and in the field of machine learning, there are lots of algorithms, predefined algorithms are available that we can be used it directly, and we can build such kind of the intelligence, or we can use it for building some intelligence software, right? For the machine learning purpose, we can be use it. So the Python is, so the first thing is you should have idea about any one programming language. Then we can use some different platform and we can write a coding and on this platform, and we can implement this particular part. So we should have idea about any one programming language, like a Python, like R, like a MATLAB, like a Java, like a JavaScript, any one programming language, C, C++, any one programming language. If you have idea, so you can work on particular, you can learn AI, and you can build such kind of this intelligence software. So it's depend on you. Like if you're good into the Python, if you're good into the R, if you're good into the MATLAB, if you're good into the Java, if you're good into the JavaScript or C#, .NET, any programming language, you can be use it. There are lots of the platforms are available which support this programming language, where we can go and do the coding and implement it, deal with the data, deal with the algorithms, and build end-to-end module. Okay, so scikit-learn is one of the very famous library that support to the Python. So if you're using a Python, so this is the for you. Okay, and you can use a scikit-learn and some there are also like lots of the particular algorithms are available, and that we can directly import it, use it for linear, logistic, k-nearest, support vector machine for different purpose, and build the solution part. So it is a free of course and widely used into the field of regression, classification, dimension reduction, supervised, unsupervised machine learning algorithm, data analysis. We use it. Okay, and it's very open source and the free, so that we can be use it. Okay, and very good documentations are also available on the internet, so we use it and learn this particular part. This platform, yeah. Second is a PyTorch. Again, the PyTorch is very famous platform. Mostly the data scientist, machine learning, or for researcher, they prefer the particular PyTorch. Okay, so the PyTorch is again is a free. There's no any license. We don't need to purchase any particular license for it. Okay, and the PyTorch is also can be used on the cloud platforms, and various high-level libraries are available for the deal with the deep learning, machine learning, different applications we can be design it. Okay, but it's based on the Lua, and which is something one of the programming language that you can see. Okay, and something is also the Python. For the Python is also available. So if you're good into the particular if you can also use good into the Python, so you can use a PyTorch and write a program, do the coding, and implement this all over the part. So lots of IT industry, they generally prefer Python and R. Lots of the university and research industry, they prefer MATLAB. Okay, and but then again up to the particular industries, their particular depend on the particular employees or any expert person, they can be use it. The main thing is you should have idea about the AI. AI is standard. Okay, and just to implement this particular part, we can use any programming language, we can use any platforms, and build up end-to-end applications. Okay, then again, that's TensorFlow. TensorFlow is very famous nowadays. All the industry, they're talking about the TensorFlow, and they're using the TensorFlow for implementation of the deep learning algorithms. And it's provide the particular JavaScript library, which is based on JavaScript, and that is we can use it for machine learning, for the deep learning, for all different AI applications we can be built using to the TensorFlow. And its API is also available for the Python, for the Pythons, or for R, for different programming language. So even if you know the Python, so you can use the TensorFlow APIs, and you can work over there, and you can use the TensorFlow functions, design neural network, design deep neural network, you can perform all of the things and build end-to-end applications. But if I talk about if I talk about some of the crowns of it, so it's difficult to learn. The thing is, now the TensorFlow in the September, they launched their new version, TensorFlow 2.0, which is very easy and user friendly. Its previous version, the version was not easy to learn it, okay, or to use it, but its new version, and there are lots of the varieties are available for Android, for the light version, for develop the web applications that we can be used it. And also like APIs are available for the Python, R, JavaScript, for different we can be used their particular functions. So if you're good into the Python, if you're good into the R, or if you're good into some other programming language, so that you can be use their APIs and you can use their functions to build end-to-end application. And one of the good thing is the free of course. We don't need to purchase any license, anything is a free of course. We can go to the TensorFlow website and we can use the APIs and use it. Weka, most of the particular Java persons or Java programmer, they use a Weka, and that's something widely used. Mostly like a Java person, they use this particular Weka software to implement the machine learning, deep learning, and to build end-to-end architecture to deal with the data, to implement the particular regression, classification, clusterings, visualizations, all these things. They generally prefer the particular Weka. So it's very famous platforms, and okay. And using this particular part, we can build end-to-end applications. And okay, so it's very easy to understand it. But one of the things is there are not lots of documentations are available that we can be use it and for learning process and build the different applications. But the good thing is it's a free of cost. So we can go to its official website and also explore this particular platform, and that we can be use it to write some code into the Java and deal with the data and all these things we can implement it. Then KNIME. So this KNIME platform is also widely used for data analytics, for the reporting, and for data mining process. And their APIs are available for integrated with the C, C++, R, Python, Java, JavaScript. So you can see for the Python, lots of things are available, and Python is also open source. So if you for the download the Python software, you don't need to purchase any license. It's open source, and lots of the APIs are available for the Python, like Python in the Python, and even the lots of the frameworks are available. Lots of the documentations are available for the Python. So even if you're good into the Python, or I'll generally recommend I'll generally recommend to use a Python for developers or for the beginners, because it's world easiest, very easy programming language and very powerful, very famous programming language. You can easily learn it even you don't have any background or any experience with any programming, okay, any particular programming field. So on it, this particular programming language, do the coding and implement or build end-to-end AI application. Okay, so even most of the IT industry, service industry, manufacturing industry, they also prefer the Python, because there are lots of APIs are support the available for the Pythons, and also it's a very open source, and lots of the documentations are available. Even you can see from starting for PyTorch, all of the things that we can do coding on those platforms using to the Python. Okay, so one of the good things about is this KNIME platform is very easy to learn it and deploy and build end-to-end applications. Okay, but it's very difficult to build some complicated model. So some normal models we can be build it using like a linear regression, logistic regression, decision tree, random forest. Such kind of algorithm we can be easily deal it, we can easily build it. But if you have very complicated algorithms, like if you're planning to build it like a particular deep learning, GAN, autoencoder, or such kind of the very deep learning algorithm, so it's very difficult to build it. Okay, and so it's again very limited for the visualizations and purpose also. So the free of course is good thing. Okay, so we can office the website, the KNIME, we can go and explore it. Now everyone is nowadays using the Google Colab, and the reasons is the free of cost, and we can use Google CPU, GPU, TPU. You see, now we are not talking about the 1 MB, 2 MB of data. Your data may be in the GB, 10 GB, 50 GB, in the TB also. Okay, and we require some system which can process those data, and where we can write the algorithm and we can perform all the computations. Okay, so we require very good resources to in order to whenever we deal with the deep learning algorithm, whenever we building some applications, we require very huge amount of we generally work with a very huge amount of data, and we require very good processors or very good system which can perform or process this entire data or build and to deploy of this particular purpose. So here Google provide, we can use a Google virtual machine, and we can use a Google CPU, GPU, or TPU even to process the particular data, and yeah, to process the entire thing, write code. So we can just go to the Collab official website, okay, and there will be some different like a Jupyter notebook where we can write the particular all over the course and implement it. And one of the good things is it support Pythons. If you're good into the Keras, OpenCV, or TensorFlow, all of the things are available, so you don't need to install any libraries. All these libraries are pre-installed. You can easily mount with the particular Google Drive. So if you have some data on the Google Drive or locally, so you can load it on the Google virtual machine and implement this all over the part. We can start the kernel as a particular GPU, TPU, free of cost. We can be use it and perform build end-to-end analytics. We can perform it, build end-to-end AI applications. We can be do over there. Now, for the .NET users, you see that we discuss R, we discuss the Python, we talk about the Java, we talk about the JavaScript. Now let's talk about the .NET. For the .NET user, they can use this Orchid platform and use this particular platform to write the codes and to implement the machine learning, artificial intelligence to deal with such kind of the algorithms, or build the regressions, classifications, recommendations, such kind of the solutions. The .NET users can use this platform and easily build end-to-end applications over there. Okay, it's a free of course, another good thing, but the thing is that not lots of the documentations are available. Okay, and again the thing is only support to the .NET, so only the .NET people generally prefer this particular .NET user. They generally prefer this particular platform to build the application. So official website .accord.net that we can go and explore it. Now let's talk about the Keras. How everyone is use the Keras API. The reason is very user friendly, simple to learn, explore, and powerful algorithm that we can be draw and build it, that we can run on the GPU and CPU also. And all the deep learning architecture, typical architectures, we can easily define using to the Keras framework, okay, or the using to the Keras libraries, which is support to the Python, and we can be use it. So it's a very fast, easy prototyping, very easy to use it, and fast prototyping, and it's we can easily use it to design different neural network, convolutional neural network, LSTM, RNN, autoencoder, transfer learning concept. All the pre-trained model we can load it and build the end-to-end applications, and it's very easy to learn it and explore it and build end-to-end applications. We can be run over the CPU, over the GPU, so that's something we can be do, and again it's free of cost. Okay, and official website is Keras, so that we can be go and explore this particular Keras.io. We can explore this particular part, so it's very famous nowadays and widely used. The data scientists, or they generally prefer this, use this platforms or the libraries, they use it to build end-to-end applications. Rapid manner, that again mostly like data minings and data analytics, or building the predictive models or text minings. We can use a particular rapid manner, such kind of the platform. It is UI basis and we can be easily use it. Okay, so it's also very user friendly, and in industry they generally people prefer this particular platform for the data mining analysis to build the deep learning part. We can be easily use it, but one of the bad thing is it's not free of cost. Some of the basic plan is available that we can be use it, but based on the requirement we can purchase it and use this particular platform. Then again, official website rapid manner, we can go and explore this particular platform. Yeah, so you can see one platform does everything: machine learning, deep learning, data mining, data analysis. All these things we can do on the rapid manner. One platform does everything. So now let's talk about, so we discussed some different platforms that we can install it in our systems, or we can go on their website and build the application. We can use their framework, their APIs that we can be use it. Now let's talk about some of the very famous platforms or services delivered by the provided by the particular Microsoft, AWS, SAP, Google, IBM, or the Uber. We can all the industries, now all the industries working on AI, and they also providing a different solution. If I talk about the top cloud service provider like AWS, Google, IBM, Microsoft, They also provide lots of services related to the machine learning, deep learning, cognitive services. They generally build end-to-end application. They also have the industries to build or to implement such kind of the applications over there. So Microsoft ML Studio is very famous. So even if you don't have idea about if you don't want to write a code or write a code, so you can we can use a Azure ML Studio platform. Is something drag and drop, and we can easily connect all the dots and build end-to-end application and deploy in the production environment. But for that, you should have a basic understanding of machine learning and AI, the architecture part. Then we can just use the cloud platform, and we can easily drag and drop and build end-to-end applications. We can be design it. Second is AWS SageMaker. It's again very famous. Amazon Web Services. So it's provide lots of the services related to the machine learning, artificial intelligence, business intelligence, cognitive services are very famous. That we can go to the aws.amazon.com. Their AWS SageMaker cognitive services is very famous. Even the industries are use it. So even we can do the write a code over there, or we can use the some services, some APIs. We can be use it to build different applications. The SAP is again very famous platform, and their machine learning services we can be used it. Google AutoML, their services are also very famous to build all the applications. Uber, their particular AI services or deep learning APIs that we can be used it. IBM machine learning, IBM Watson's data science and machine learning platform that we can be used it. So you see, this all industries are very famous, and their services that we can be used it to build end-to-end applications. Okay, and or either like we can use their services, we can use their some product, AI-based product, and we can use their APIs to build or integrate with our application and build up, solve the particular business problem. Or we can also use their virtual machine where we can install all the software. Okay, if you don't have such kind of the infrastructure, so we can use such industry the virtual machine, and we can install all the softwares and we can work over there. Yeah, that also we can do. And if I talk about the learning process, so you see in AML, in the artificial intelligence or the machine learning, there's 80% mathematics. That's why nowadays college students, school students, or even professionals, all ages of the person, all the backgrounds of the person, they are learning of the particular artificial intelligence, because we just require some basic understanding with the statistics and some basic linear algebra, and just we use some programming language to implementation purpose. If I talk about all over the hierarchy inside of the AI, so if I talk about the infrastructure, so we just require some hardware where we can process this all the particular data. Okay, where we require some hardware like CPU, or particular we can use some big data infrastructures, or we can use some CPU, GPU for the computation purpose. Different machine learning algorithms that we can be used it, like based on statistics, based on the probability, the different algorithm that we can be used it to process those particular part. And for the different technologies like computer vision, speech processing, NLP, natural language processing, planning and decision making process, big data, for different purpose that we can be used it. Okay, and technologies for different technologies for like for sentiment analysis, image recognitions, and we can build different solutions for all other kind of industry like healthcare, security, traffic, games, augmented reality, healthcare, and finance sector. We can design different applications of it. Okay, so it's very important is on the bottom layer we require some particular hardware where we can process this all the data. Okay, and then we use some algorithm to build some application. Then technology direction is also very important, like a particular the business, the main objective, or the particular like whether like you want to design it for the computer visions or for the NLP kind of thing, or business in the planning sector. So the domain knowledge is also very important, the technology direction. And then after, for the different industry solutions, we can be design it. Now let's talk about the data, because it's again very important. So as you can see, the data is something particular fuel for AI, and algorithm is something engine for AI, because these are the very two important things. Okay. So as we see, the human's machine can a particular algorithm, and with the help of the algorithm can learn from data, books, or the information, and become the intelligent into the similar way like a human and perform some actions. But again, the question is how to implement into the real world. So we discussed that different techniques, we discussed that different platform that we can be used it to write the code, and there are the different algorithm that we can be used it, okay, and build the applications part. Okay, but how to implement into the real world? What is the flow chart of it? Okay, so like it's not something like we have a data and directly we can start with the algorithm and start a training process. We spend lots of the times to prepare the data, because in the real time data is there, maybe the loss of, there are lots of the garbage, lots of the none values over there. Okay, so we generally data scientists spend lots of the time to do the pre-processing, to clean the data, to do the change the formatting, or for scaling, normalizations, aggregation. So they do lots of things like a feature engineering, feature selections, okay, feature importance, feature extractions, labeling and coders, okay. And then after they perform the particular, once they have a particular very good data sets, then after it's perform the particular machine learning task. But now let's understand the particular all over the flowchart and end-to-end flowchart. So as you can see here in this diagram, it's very important to as you can see here, whenever we start with AI projects, okay, let's suppose as a data scientist, so whenever you start to work with any projects or any things, any particular projects or designing the solutions for any industries, so we spend lots of this time to understand business problem, to understand objective. What is objective? Generally, a data scientist arrange lots of the meeting, many times arrange the lots of the meetings with the clients and to understand their actual requirement. Okay, they set the particular final objective or the goal. Okay, and let's suppose that if I'm working into the particular banking industries, now if I got some, now from the last 5 years I'm dealing with the particular, I'm handling the project of the banking industry. Now today all my senior managers give me some project related to the manufacturing industry. So then now I'm very expert and become familiar with the particular deal with the business data set or banking data set. But suddenly if I got some project related to the manufacturing industry, so I have to do lots of research to understand all the variables, all the terms, because otherwise I won't be able to do interpretations. Okay, so general case, a data scientist spend lots of the times to understand the problem, understand the data, okay, understand all the variables. So that's why nowadays AI is also become very famous for experienced person also, because now all the industries, if someone is working from the last 20 years, 25 years, 30 years, so I can say that the person have very good understanding with all of the business data set, all the variables, they are very familiar. So now, as we know, to implementation of AI, we require a domain knowledge is very important. Domain knowledge is very, very important. So now all the experienced person, they are using artificial intelligence techniques or AI algorithms, okay, they're using it and they're understanding all AI architecture and becoming the AI expert on their domain. So data understanding is very important. And in the data understanding, the data scientists spend the lots of the time to understand all the variable, all categorical, all continuous, all the kind of variable, and they try to relate with a particular business problem. Okay. And once they are good with this particular part, then after they move on third step or the next step, that is a data preparation, where we prepare the particular data, or the data analytics team, they generally prepare the data, or they generally clean the data, feature selection, feature importance, or particular feature engineering. Okay, so do the lots of things and prepare the particular data, and then after perform the modeling, where it's use a particular AI algorithms to build some kind of the predictive models, or to different algorithm to which can solve the particular business problem and do the modeling part, and then check the they check the particular accuracy. If accuracy is good, then it's fine. It's generally send the particular final model for the evaluation purpose. But if the accuracy is not good, then again it's come back to the particular data preparation and do some hyperparameter tuning. Okay, and they try to improve the accuracy of the final model. Then after this particular part, with the help of the domain expert persons, or particular with the client, it's do the particular evaluation and check the particular performance of the trained model. And if once they are satisfied with the evaluation part, then they deploy on the production environment, deploy in the particular production environment and do the particular testing on the real time. So this is something how we generally do or implement build any AI project. So generally into general case, the data scientists or the particular development team spend lots of the time to understand business problem, to draw the architecture, and to relate the particular individual variables with the business problem, and also to understand all about the variables. And then after, they move on the particular data preparation, where they prepare the data, perform the different operations to clean data, to do the particular to transform the data, like a different operations like a feature selection, feature engineering, feature extractions. Okay, and once we have good data set, then after they perform the particular modeling operations, where they use the particular artificial intelligence or AI or based algorithm to build intelligence and learn from build intelligence, and then after they check the particular training accuracy or model performance. That is something a part of the evolution part, and once they are done with this particular part, then they deploy on the production environment and do the testing part. So this is something how we do a particular build any AI projects. So let me just here, as you can see, all over the charts as whatever we discussed till now. Okay. So machine learning is a subset of AI which use data to build intelligence. And there are three types. One is supervised machine learning, which use a particular label data set and which can be used to predicting some future value, classifying, okay, and it's use a particular label data sets, or it's learned from the historical data, okay. And mostly like industry nowadays, they use a supervised learning and machine learning algorithm. And supervised learning algorithm, we can build three different problems we can be solved, like predictive model using a regression, classification, and tendencies forecasting. Forecasting and prediction, two are both different things. Okay, like a sales forecasting, weather forecasting, we can do that. Classification means when in our data set the target variables is something categorical, or we want to predict some particular classes or the label. So in that case, we can use a classification algorithm. Some of the applications are churn prediction, digit classification. For the regressions, that when the particular target variable is a continuous variable, so we can use a regression algorithms like housing price prediction, age prediction. So in this case, we can use a regression algorithms. And we discussed like unsupervised learning algorithm, which is use unlabeled data sets. Okay, unsupervised learning algorithm use unlabeled data set, and using that we can design the clusterings. We can define some anomaly detections or dimension reductions or particular recommendation system. Recommendation system which can give the different recommendation for the product or the services to the end users. Dimension reduction is used to reduce the particular dimensions of data, and anomaly detections to detecting a particular some suspicious activity on the real world. And clusterings is used for to design different kind of the clusters, and all the data points inside of the clusters is represent the same kind of the information. After we generally also say, so whenever we have a data, so generally what we do it, we split the data into the training and testing. And training data set we use for the train the model, and model learn from the training data set, and after it's do the particular evolution with the testing data set. And if the performance is good, then after a developer, the development teams behind it generally deploy the particular final train model on the production environment, and then the customer or the people's users can do the particular testings in the real world. It's also very understand to all about the framework. It's also very important to understand all framework. So as you can see here, so normally we perform all these 10 steps. Okay. Normally we perform all these 10 steps to complete any data science or any particular AI projects. So the first step, as you can see, as we discussed, that is very important to understand business problem. Data is very important. So the first step is data exploration, domain knowledge, gather more relevant data from business or from the outside. So it's very important. So whenever you are working with any data science, any AI projects, so the first we spend lots of the times to understand data, to understand all the variables inside of data, to understand business problem or the particular client objective, all of the things. And then after, we also try to relate all the particular variable inside of data with the business problems, and also collect more relevant informations related to the particular data or related to that particular industries from the outside or from the inside of the industries. Then after, once we're done with this particular first step, Once we are done with this particular first step, then after we perform data cleaning, because into the real world, data is not into clean. Maybe there's some values are missing. Maybe there's some values are there are some values are missing. Maybe there are some non values. There maybe there's some garbage inside of data. So the task is to clean particular data. Okay, and if the business allows you to replace this particular none or the missing value through the statistical way or through the machine learning algorithm, then we can do that, or either we can drop that particular complete rows or complete columns, and complete rows, and remove that particular sections, or otherwise we also use some statistical way to replace or to fill the particular missing value, or to replace that particular garbage data. So it's very important to perform the data cleaning also, because if you have a good data, so model can get the particular good accuracy. So maybe we'll get a good trained model. Then after next step is a feature extraction. So here is also very important. So we perform, whenever we have a data, we export the data also and collect the lots of information, find the particular objective. Then after we perform the data cleaning. Then after we perform exploratory data analysis. Exploratory data analysis, EDA, is widely used to understand or to find the particular, to understand or to find the insight from the particular data, or to get all over the past events, okay, or to extract the particular information from the particular historical data. We perform the EDA with the help of the statistic or graphical, or the particular graphical techniques or visualization techniques. Okay, graphical analytics or the visualization techniques, we perform the particular, generally we perform the particular exploratory data analysis. Okay, and then after we perform the feature engineering, where we do the feature extraction and feature selection. Let's say you have a 10 features, but maybe all the 10 features are not important. So we perform the feature selection, and which features is important, which feature is not important, that we do that, and we select the relevant features and prepare the particular right data set. And also feature extraction is very important. Let's suppose that you have a particular some features like age of the particular customer, but generally the bank industries or the particular insurance industry does not store the particular data or information of the customer in the form of the age, because every year is going to change. So they save this information in the form of the date of birth, okay, or the year of the particular birth. So here this is something of feature extraction part. Then after we go with the data pre-processing, where we do the particular labeling encoders, and we process the particular, prepare the particular scaling to prepare the data for the machine learning algorithm. And once we are done with this particular part, based on that, how the different independent variables are connected to each other, what is the problem statement, based on that we select the right machine learning algorithms and we start a training process. We do hyperparameter tuning, and we try to achieve the good accuracy. Okay, we do perform the performance analysis. Then after we do the tuning part. Through the tunings, we try to improve the performance of model. And once we are satisfied with the particular model, so we can export the model, deploy in the production environment, and monitor it all over the performance for some couple of times. Yeah, we can monitor it, and we can check it whether like model is performing good or not. So this is something all over the steps we follow whenever we design to any particular projects, any kind of the productive models that we do use it. So data visualization is again very important. As we discussed, EDA play a very, very important role to find out the past event or to perform some data analytics is very important. We spend lots of the times to analyze the data to find the hidden patterns or all the hidden information or hidden story, you can say. Okay, and in order to understand those or interpret the story or to find the story, we should have a particular domain knowledge also. We should have understanding with all the variables, then only we'll able to create story or find the story. It's not something you can plot a graph and you can create the story, or we can find the particular stories or all the relevant, all the hidden information. If you have a domain knowledge, or if you have a data knowledge all over the variable informations, knowledge of all over the variable, then only we'll able to perform this particular part. So in this case, let's suppose that we have a different variable, and in the data set, maybe you have some variable as a categorical, some continuous variable. So continuous variable like a credit score, which contains some data in the form of the numbers. Categorical variable which contains some categorical data like a gender, religions of any particular person. Okay, So we perform it univariate, bivariate, multivariate analysis. So generally into the univariate analysis, we select the single variable. We check their frequency if this is something categorical data. If we have continuous variables, so we check the distributions of data and we try to extract the information. Whenever into the bivariate analysis, we select the two different variables. Both variables may be categorical, maybe the both are continuous, and maybe one is categorical or one is continuous. One is continuous and one is categorical. So here also we use a different kind of the graphs like a box plotting, swarm plots, or frequency tables, or histograms, different technique that we use it, different kind of the statistical method like mutual information, ANOVA, chi-square, and we perform the bivariate, multivariate such kind of the analysis. And sometimes we also perform the dimension reduction techniques to reduce the dimension or clustering for the data mining process. So we process this, we follow this entire step for the EDA, and in order to understand the behavior of the individual variable or the data, or to find the insight from it. These are some, as we discussed, as the same, maybe into the real world, we may have a particular 50, 20 or 100 features. So we also perform the particular feature selection. So there's a different technique that we use it to select the particular features and to find that which feature is important or which feature is not important. See, as we discussed into the supervised machine learning algorithm, we have a label data set and we have a lot of independent variable and dependent variable. So all the independent variables also known as a particular features, and your independent variables or the features may be the categorical or continuous. So we use a different technique to process the particular feature selection like ANOVA, chi-square, clustering, mutual informations, machine learning, let's so backward and forward chaining, and features importance and or mutual information or variance or variability analysis, correlation analysis, data visualization, different techniques we use it for feature selection process. Some different techniques like how to choose, how to select the right method, how to select the particular right method. This is again very big challenge, like how to select the right methods to perform the analysis, that because we have a lot of techniques that we can be used it. And as we discuss into the real time, we may have a categorical or continuous variable. So if let's suppose that you have a single variable like a credit score of the person, this is single variable are continuous because it contains some numbers, right? Some data in the form of some numbers. So what we can do, we can perform the univariate analysis and we can check the distributions of data, and that we can do using to the scatter, using to the a particular plot like distributions of data, we can be check it. Then again, same time, like if you have single variable as a categorical, then we can perform the particular count plot and we can check the frequency of the each category. If you have two variables and the both variable are categorical, so in that case we can use a bar plot, we can use a count plot, we can use a chi-square, we can use a mutual information, histogram, and such kind of the techniques that we can be use it to analyze that particular data or to perform the bivariate analysis. If you have two variables and both variables are continuous, let's suppose that you want to check it, what is the relation between the dependent or independent variable inside of data. So we can use a correlation, we can use a scatter plotting, we can use ANOVA, we can use a mutual information, and from that we can understand the particular relation between the two different variables or two different continuous variable, whether like they're having the linear or non-linear relationship. Similarly, whenever we have a data like one variable is a categorical and one variable is a continuous, so we can use a probability distributions analysis, swarm plotting, ANOVA, mutual informations, such kind of the techniques that we can be used it to perform the to analyze such kind of the variables. Okay, so it's very important. As you can see, you have a data. The first thing we apply statistical analytics, graphical analytics, different techniques we apply on data and try to analyze it, try to find hidden pattern inside of it. We spend lots of the times to analyze all over the data and extract the information, different technique that we use it. And once we have all over the information, based on that we can select right features or we can perform the feature selection operation, and we can select that particular right algorithm for the given data set and perform or build end-to-end application. And again, as we discussed in the, there are lots of algorithms like linear regression, like logistic regression, like support vector machine, like a decision tree. And so how to select, or like a deep learning algorithms like a convolutional, recurrent, LSTM, GAN, autoencoder, then there are lots of algorithms. Then how to select the algorithm and build the application? So selection of algorithm is depend on the lots of features. The first is type of problem, whether you have a regression problem or the classification problem. So like a KNN, we can select for the regression and the classification, like K nearest neighbor algorithm. We can select or we can use it for the regression and the classification both purpose. Linear regression we can be used for the regression purpose only. Logistic regression we can be used for the classification purpose only. Okay, and naive Bayes algorithm we can be used for the classification purpose. Decision tree we can be used for regression and classification both purpose. Random forest we can use for the both things, and neural network we can also use for the both things. And whether like you want that result should be interpretable or not. So KNN result is interpretable and linear regression is yes interpretable, and then logistic into the some level is interpretable. Same thing for the naive Bayes also, and decision tree be yes, and for the random forest is very little, and neural network is not particularly interpretable the particular final result. Easy to explain the so you see based on some set of the variables, like whether like it is easy to explain or not, or average predictive accuracy. Okay, whether like training speed is something high or something or moderate or slow. Okay, or prediction speed. Okay, or the particular amount of parameters for the tuning, so it's having the loss of parameters for hyperparameter during to the that we can be tune it to improve the accuracy. Okay, so as you can see, the based on amount of the parameter or training speed or prediction speed or average prediction accuracy or interpretability or a particular type of the problems, and again some more different features like parametric. Okay, or the particular whether like it's performed with the small data set or not, because in the most of time in the industry we have a small data set. Okay, and whether like it's working with the noise or not. Okay, whether like it's able to learn automatic or not from the features. Okay, and whether like the result is we can give the particular result in the probabilistic result or not. So based on particular some, or whether it's requires some scaling or not. So based on lots of factor, we can select or write algorithms. Because to work on algorithm, to work on AI project into the normal time and to for the production in industry, it totally different. Whenever we deploy the particular any model into the, whenever we build any software or AI algorithm for any production industries or any IT industries, so it's depend on the lots of factors, like what is the prediction speed, what is the training speed, how much computation power required, the infrastructure required, data, whether like it's worked with the small data or not, whether it's require very huge amount of data, or whether like in the data if the noise will be work or not, or result will be interpretable or not. So it's work on the loss of factor, and basis on those factor, by keep in mind all of these factors, we can select the algorithm and process this particular process. Select the algorithm and process the entire part. And selection of the deep learning, as you can see. So again, we already discussed here based on some of the features, but there are also some more graph that we can understand it. So as you can see through this particular chart here, if you have something predictive value is something numeric, so we can use a supervised machine learning regression algorithm. And if you want very high accuracy, so we can use a random forest neural network gradient descent based boosting algorithms that we can be use it. If you want the high speed, so decision tree and linear regression that we can be use it. If you the problem is something classification and high speed, for that for the accuracy we can be use random forest neural network. And if you for the high speed and with the particular, it should be very explainable, so we can use a decision tree and logistic regression. And with the speed we want a speed, but it should be not highly explainable, and data set is also too large, then we can require the large, then we can use a naive Bayes. If you have a particular database is not something we have a huge amount, so we can use a particular linear SVM support vector machine and naive Bayes algorithm, we can be use it. Okay, so similarly, if you have something for dimension reduction purpose, so we can use a PCA, we can use SVD. Okay, such kind of algorithm we can be use it. Or if you want to use for the clustering purpose, okay, so the K means for the categorical or K modes or Gaussian mixture models of that we can be used, some or a particular these such kind of the algorithms that we can be use it, or particular hierarchical such kind of the models we can be use it, right? So density based clustering, that approach we can be use it. So based on the type of the problem, based on the particular the factors, like whether like you want to do the dimension reductions or you have a small amount of data, you want a high speed or low accuracy, or low accuracy or high speed, or it should be interpretable, or some different factor, we can select a particular right algorithm for the given problem statement or particular given data sets. So this is something all over part. Okay, so now I think I'm done from my side. Let me know, all of you, if you have any question. Now we are open for Q&A part.
Yes, Ashish, I'll start with the first question. Hello?
Yes, hello.
Yeah. Where are we with respect to thinking AI at present, and what will be its future?
Okay, so as of now, AI is on the very early stage. The industries are using this particular part, building the different applications, but still there are lots of things, there are lots of the research is going on. So in the future, the people will use a particular AI-based software, AI-based application in their daily life. Even nowadays, there are lots of research is going on, especially into the medical sector, or manufacturing industries are still doing that. So as of now, we are using the AI into our daily life, but still it is on the very initial stage. Lots of universities and industries are using this particular working on AI and building and designing different kind of application. Yeah. Next.
Next question is how AI takes care of region-specific legal requirements. Is there any recent developments on this?
Pardon, come again.
How AI takes care of region-specific legal requirements. Is there any recent developments on this? Legal requirements.
Legal requirement. Can you please elaborate this part?
Yeah.
Like?
Region-specific.
Yeah, I mean, I will take it, Jyoti. I think this question, what we understand here is probably might be different geographies are having different kinds of legal requirements. So as such, in the AI, whether such kind of adaptability is already there, or any kind of recent developments are happening on that.
Okay.
Is it something like the legal compliance requirements has to be pre-fed into the system well in advance, or the AI can configure itself, or it can, I mean, this is what we understand. Maybe we are not very clear about the question. If the question is not clear, maybe we can move forward.
Yeah, that's something I need some more information, because still there are lots of industries that are designing AI applications for the legal industry, into the laws, and even especially like US to process all the works. So there are lots of applications are already in the market, or startups or the industries are designing to process the legal works. They're using the artificial intelligence, building different solutions part.
Yeah, as that question was from anonymous, we are not aware who has sent it. Maybe whoever has sent it, could you please elaborate your question, and we will be happy to answer to you. Right. Over to you, Crystal.
Yes.
Next question is, humans, we can transfer learning in one context to another. Can AI transfer the experience or learning from one set of circumstances to another?
Yes. So this is here known as a transfer learning concept. Like humans have a capability to reuse our knowledge. So similarly, in the AI, the transfer learning algorithm or transfer learning concept is very famous, where we use a pre-trained model with some other applications, and then after we use a retrain, we use that particular pre-trained model for the other. We use it to build some different applications also, where we can do some freeze the model, we can do some kind of the changes. So let's suppose that we have designed some AI application or AI model which can recognize that, which can classify that whether like particular animal is a cat or the dog. Now same algorithms, we can also use it to recognize or to classify some other animals or to some other object, but not entire AI portion, some portion of the knowledge we can be use it. So here we can use a transfer learning of concept. We can load the pre-trained model, we can freeze it, and we can retrain with some small amount of data set. And due to this particular part, we can save loss of the computation power, loss of the effort. We can save it time, we can save it. Okay, and we can be reuse that particular some portion of the experience that we can be use it to for the different applications. Okay, so next.
Okay. Could you please throw a light on AI applications currently used in oil and gas companies?
Yes, oil and gas companies nowadays are using AI and combination of IoT. That is something predictive maintenance, detect the particular leakage or predictive maintenance, or they are using the industry 4.0 because now all over the oil and gas industries they want to improve their building a different applications of based on industry 4.0, okay, where the particular continuous for the continuous manufacturing or for leakage detections, okay, or for automate the all the process. So where AI play a very important role. Now AI and oil and gas industry using the IoT to collect the real-time data from the machines. Then after they can be used artificial intelligence algorithm to build some predictive maintenance or recommendation solution. Okay, let's say if they can be used AI algorithm to build some software, intelligent software, which can predict some kind of the failure. And if there is something very high probability, so the AI algorithm is going to send the alert to the operator or the maintenance engineer. At the same time, a recommendation engine will give the different recommendation for the particular operators, and also for the maintenance engineer can use those recommendations and to resolve the entire thing within the given time frame. So now oil and gas industry are also using the artificial intelligence and IoT, such kind of the technologies to build end-to-end solution. Yeah.
Next question is by Sarah. Question is how AI is responding to COVID-19.
Yes. Nowadays, industries are using artificial intelligence for drug discovery, for designing the vaccine, and even the artificial intelligence is also the government bodies are collecting a data. You see, like Indian government is also launched different Android applications, and through that they are collecting a data and designing the using a statistical techniques to building a to understand those data, and also the using the AI algorithm for the different startups and the particular pharmaceutical companies are using AI algorithm for the drug discovery for designing the vaccine. And also there are some applications are available, AI based applications are available to predict that whether like person is having COVID-19 or not based on some set of the features. So there are some AI applications are available. Some of the research teams, they already designed that the applications to do the testing where they can just feed some features value. Or recently one research team, they designed some applications so where based on the curve, okay, the audio of the particular curve, the particular model can be predict that whether person having the COVID-19 or not. But still there are lots of the research is going on, because you see, if we have good amount of data, so then we can build a very good solution also. So it still be the teams, research teams and universities and companies, they are trying to collect the more and more different type of different data from different countries, different peoples, different organizations. They're trying to collect it and building their applications. Yeah.
Okay. And next, how AI is changing banking sector?
Yeah. Nowadays, of all the banking, finance, all industries are using artificial intelligence. Like till now, like industries, especially like banking industry, as of now, they use RPA, robotics process automation, such kind of the software to automate their functions area or the some kind of backend work. Okay, but nowadays RPA software is also AI, and even the particular banking industry is using the AI to for a particular improve the security features, okay, to predict the particular threats, and also to providing the better services to end customers. Even JP Morgan and some of the industry who build the applications for the banking industry, they are using they are designing some applications or software for the different bank. So through that they can be predict that this particular customers will be call us or contacts us in the future for such kind of the problems. So, and they are designing such kind of the applications, and they will be trying to resolve it, the customer's query, before they will call or face such kind of the challenges. Even now, the company also deploy lots of the board you see using to the mobile applications of any bank. We can check it, and we can see, we can just send some features value, and we can check it whether like we are eligible for loan, credit card or not. Or even the banking industries are using for the chatbot applications, they are using the AI, which is based on deep learning algorithms. Even the particular facial recognition based or locking system, or particular lots of patterns, they are using AI based algorithms they are using to build a different kind of, to improve the security features or to provide a better service to their end customers. Yeah.
And this is also from Anonymous. Could you please throw a light on AI applications currently used in oil and gas companies? That was answered.
Yes, we already discussed.
Yeah, okay. That 1 second. This question is also from Anonymous. Will AI take over teaching? Technology replace a teacher?
No, I don't think so, because a particular AI can only do things whatever we have done, because in order to design the AI software, in order to design the particular AI software, first thing is we require the huge amount of data. And but because the particular teachers can use the teachers are very experienced and intelligence, we cannot compare a software with the teachers or any particular humans, because human can imagine anything, human can explain anything into the very different way, and this is the only the such software. So there is no any comparison between the human and such kind of the AI based software. We are very smart, and for the human there is no level of intelligence level of the particular human, so we are very intelligent, and the AI just we can design some small software, but I can say it will improve the experience for the learner. Okay, improve their learning experience. AI will help to improve the particular learning experience, but we cannot replace teachers. It's not possible even. I don't think it's basically. Yes.
Next is Watson AI or ML?
Sorry?
Is Watson AI or ML?
IBM Watson.
Yes, I think, but from this question is from Anonymous. They are asking is Watson AI or ML?
If I say, if your AI and ML is not two different things. If you're working on ML, so it is something AI. Okay, so AI ML is not a two different things. It's not something AI is something different and ML is something different. ML is subset of the AI is a collection of algorithms, and ML is something algorithm which use a particular data. You see, AI is the different algorithms. Some of the algorithms we use for searching algorithms, or for genetic algorithm, fuzzy logic based system, rule based system. Okay. So if you're doing the particular ML, so it means that you're doing the AI only, because ML is a subset of AI, and IBM Watson and different services they provide lots of services related to the AI, different AI algorithm based on the deep learning, normal machine learning, searching algorithms. It provides lots of the services related to the AI. Yeah. But both are same thing. Both are not different things. ML is subset of AI. So if you're working on ML, it means that you're doing the AI only. Yes.
Okay.
Next.
Next question is also anonymous. How AI is being used in education?
Even you see the recently in the particulars in India, like CBSE boards, they included AI into the for the school student as a optional subject, and now for implementation of for the learning of particular AI is we just require the basic statistical basic knowledge of it, like basic linear algebra. So now school students are also learning and building the applications. So mostly you see the school students, they talk about what is the use of mathematics, but through the AI they will able to imagine the actual use of mathematics, because here we actually talk about the mathematics, the interpretations, we use it and build different kind of the applications. So now the school students are also using the AI to clear the different concepts, and also there are lots of applications are available, AI based applications are available to in the real time that we can be deployed in the classroom to check it, like whether like teachers are explaining the things very well or not, or whether like a particular students are listening or attending the sessions, okay, or like collecting the informations or learning into the very accurate way or not. So through the pattern recognition, so there are lots of way, yeah, the should in the education sectors we can be doing. Even the now AI is also helping the education industries to, you know, like to improve the to provide a better service, right? You can say to improve their experience, you can say that, yeah.
That was the last question, Ashish. Thank you very much.
Okay, then thank you to all of you. Have a
Yeah.
good day. Thank you to all.
Yeah, Ashish, I have a question from Anonymous.
Yes.
How AI is changing the banking sector?
Yeah, now all the banking sectors are using AI. If I talk about the Axis Bank, ICICI Bank, they're also using nowadays a physical robot to provide the better customer services. Even you see now all banking industry, they're collecting a huge amount of data for their customers, and they're using building a the churn molding. So let's say in the recently, like all the industries, they are using a particular AI algorithm to building the model for churn prediction. Means let's say what is the probability of the particular customers they will exit the bank, okay, and then based on that they can provide some better services, okay, or to analyze the past events that they can be use it, or to chatbots for provide okay, but better customer services or to resolve the customers queries, okay. And also industries are deploying the particular AI based robot into their banking to provide a particular to resolve the particular customers queries, and deploying the different AI software integrate with their own production or network to improve the security features to predict the threats, okay, and provide the better customer service. Yeah.
All right. There is a question from Samara. Will AI predict the future of healthcare?
Not predict the future of the healthcare, but is widely used it for in the healthcare sector to understand the medical images, okay, like CT scan, MRIs, or X-rays. We can be using drug discovery or particular vaccine, okay, to create a particular vaccines or early diagnosis, that we can be used it for early diagnosis. So for such kind of applications, we can use the AI. Even lots of startups, they already design some chip, variable chip that we can use on our body, and it will be collect the data, and that we can be connect with the particular our mobile applications, and they will be monitor the entire data and recommend the different kind of medicines, recommend the different kind of the based on the particular or health body or the body requirement, recommend the different kind of the you know, like foods and all parts, so that for the better health, okay. So even the all healthcare industries, they are working on AI and designing the different solution for the early diagnosis to understand the medical images, skin visions, or drug discoveries, and yeah, for such kind of applications, for that we are using nowadays, we are using the AI.
All right. A question from Samantha. Is data scientist a good career? I feel it's an interesting question.
Yes, because you see, in the data scientist, if you know statistics, if you know any programming language, so even you can learn this all over the things. So here the best thing is you're able to find the story from the data with the help of the statistic. You will able to know or understand the actual power of statistic or analytics part. Let's say you have a data, you have a lots of data. Just looking over data, you cannot extract the information, you cannot make the conclusion. But if you have knowledge about the data science, so you can easily read all of our informations and analyze all the data, collect the information. And now all industries having the huge amount of data, and it's very huge demand into the market also. So now there are lots of job opportunity, there are lots of the good career in the field of the data science. And the thing is, it is not something related to the banking or business sector. All industries nowadays, they are hiring the data scientists, because they want to improve their decision making process, they want to automate their functions area. So they want someone who are very familiar with their data set, their particular business. So that's why now all the people's experienced person, fresher, they are learning the data science and dealing with the AI algorithms.
All right. A question from Anonymous. What type of questions can data science answer?
What?
What kind of questions can data science answer?
Okay, data science answer what happened in the past by just working on the data. they answer, they find the particular, all the hidden pattern. They just see, if you talk about the particular COVID data set, if the data scientists can work on any data sets, and this, they can come on some conclusion, this thing happened in the particular past, this was some kind of the reasons. But to make the inferences, a particular data scientist should have a domain knowledge, familiar with the data, and also it can predict about the future. This thing will happen in the future, and in this way you can overcome from the particular problem by building the recommendation solution. Data scientists can build for any organization complete end-to-end data-driven solution to check it what is happening right now by using the data reporting tool. Step 2, in that they can be use it what happened in the past, what has happened in the past, or what kind of the event. They can be use it the statistic and graphical analytics and design the reports. What will happen in the future related to the business domain, they can be design some kind of the solution, and how to overcome from such kind of the problem, they can also design such kind of the solution. So end-to-end data driven solution for any organization, any industry, a data scientist can be built or design it.
All right. With this one final question, we will wrap up the QA session. Is AI replacing human touch, especially in the field medicine?
Yes, nowadays particular AI-based robot and softwares are using in the medical sector to drug discovery and all part, but we can't say that it will be replaced it. But again, yes, the AI softwares are using that. AI, the companies are designing the AI-based applications for this particular purpose. Yeah.
All right. Thank you, Ashish, for having patience and answering all the queries from various sectors the participants have asked us. Thank you so much for the patience. And I would like to thank you for your presentation, which made us understand the terminologies such as neural networks, machine learning, deep learning, artificial intelligence, and what AI can and cannot do, and also how we can work with an AI team in an organization. So it was a really and wonderful explanation presented by you, Ashish. Thank you once again.
Thank you, Don. Thank you.
All right. Now let's move ahead with our forthcoming session. So which I'm gonna present now. As you could see, yep. This is the schedule for the remaining days in this week. As of now, we have done with 3 sessions, and those who have missed the previous schedules, kindly look at our calendar and mark the sessions in your calendar. And please enter yourself in the session. Keep learning. Thank you so much. Take care. And once again, I thank you, everybody, for all the participants and also for the entire team and also the trainer. Thank you so much.